I just went outside and I can hear the rocket.
Confirmation of ignition. We are up at the
It's
desired power.
it's a rough
Tank
noise,
pressure
like
looks good. The turbine temps
sort
look
of
good.
sounds like really quiet
You may have
thunder,
seen just before
but it's
ignition
just
the
thundering
large
all
white
the
fluffy
time.
pieces moving away.
So
That is
here
solid
you can
oxygen. The
we
stuff
can't
you
see it
breathe, it's
here
so
in
cold that it's
Australia
solid,
because
but it is
at
not
the
very dense.
moment
It's very
there's a
fluffy,
lot of
and it is
clouds
actually
everywhere.
attached to one of the
But
liquid oxygen
I
overboard
reckon
drain lines that we use. So
here in
coming
the
off is normal.
United States, if
Now this
if
burn
it's
is
not
about an
cloudy out,
85
you'd
second
probably
burn.
be able to see it.
In that time, we'll add 2,800 meters per second to our velocity. That's more than the side boosters provided early in flight,
Fuck
almost as
me,
much as what the
dead.
center core gave
This
us.
thing is going 32,000 kilometers an hour.
We've throttled down the engine to keep accelerations below the limit for our Arabsat customer. Everything continues to look good. The views of the nozzle of the upper stage engine coming from 2 SpaceX cameras on either side of the second stage.
This rocket has been launching for 29 minutes now.
Continuing to throttle down, and we have shutdown.
And back shutdown.
Right now we're waiting to hear what the final orbit looks like.
Nominal orbit insertion.
Guidance engineer over one of the nets announced nominal orbit insertion. Right where we want to be, we're on a path that'll take us almost 90,000 kilometers up above the Earth. Well, now we're in the good orbit we wanted. We're going to coast for the next 5 minutes or so. We'll be back with continuing coverage at T plus 33 minutes for the final step in today's mission, deployment of the Arabsat 6A satellite.
Wow.
Welcome back. T plus 33 minutes, 29 seconds since liftoff. We're about half a minute away from the deployment of the Arabsat 6A satellite. Now currently the second stage has begun a slow spin up. That'll help stabilize the satellite. It'll retain that spin when it separates from the second stage. Now, currently the camera view has switched forward looking at the Arabsat 6A spacecraft. And if you've just joined us now, you've missed a great day. Both side boosters landed at the Cape. Center core landed, second stage right in the desired orbit. And now we're waiting for separation.
Spacecraft separation confirmed.
Wow.
The payload tonight is a geostationary communications satellite which will provide state-of-the-art communication services to customers in the Middle East and Africa.
Tonight's launch window is about 2 hours long, and we're planning to launch at the top of that window. If we're unable to launch tonight, our backup window opens up on Saturday, April 13th. We're currently at T minus 14 minutes and counting, and all systems are go in Cape Canaveral.
Today, Falcon Heavy will deliver the Arabsat 6A payload to its intended orbit more than 20,000 miles above the Earth's equator. That's significantly higher than normal, which is why we're flying a Falcon Heavy. Now let's take a closer look at the rocket. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which means it can carry much larger payloads not only to Earth orbit, but to the Moon and Mars as well. Like the Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference, of course, is that the Falcon Heavy first stage is comprised of 3 cores, and Falcon 9 only has 1. Each one of these cores has 9 Merlin 1D engines, making for a total of 27 engines overall, as you can see on your screen. Now altogether, these engines produce over 5 million pounds of thrust, equal to 18 747s at takeoff. In fact, the engines produce so much power that we don't run them at full thrust all at once until after liftoff.
I just counted all
For the
those
mission today,
holes.
each one of
And that
these
is
3 Falcon 9
27
boosters
engines.
is brand new. It's also going to be the first time we are flying Falcon Heavy with our upgraded Block 5 cores, which feature more lift capacity, a beefed up heat shield, and other changes to make the boosters more reliable and easier to reuse.
During ascent, Falcon Heavy will throttle its thrust up and down on both side boosters and the center core to balance aerodynamic and structural loads on the vehicle. About 70% of the way through the first stage burn, the 2 side boosters will separate and come back to Earth for a simultaneous landing at Cape Canaveral Air Force Station on Landing Zone 1 and Landing Zone 2. At this point, the mission will proceed just like a standard Falcon 9 flight. The center core will keep firing for another minute, then we'll perform a standard stage separation from the second stage. We will attempt to land the center core on our drone ship, Of Course I Still Love You, which is currently stationed about 535 nautical miles off the coast of Florida in the Atlantic Ocean. It's worth
I'm not
mentioning that
particularly
for
going
this
to
mission,
subscribe
bringing
because I
back the
couldn't
center
be
core
bothered
is
to.
challenging. If we are able to land all 3 cores tonight, it will be particularly exciting. The second stage is exactly the same as any other Falcon 9 flight. Tonight, the second stage will be sending our payload to geosynchronous transfer orbit. The spacecraft will then maneuver into a geostationary orbit more than 20,000 miles above the Earth's equator.
11
Now, to
minutes
put
and
that into
30
perspective,
seconds until
that's
it's in the
equivalent to
correct
almost
position.
an entire trip around the world,
Wow.
traveling along the Earth's equator.
Speaking of the satellite, it is safely enclosed inside the 17-foot diameter payload fairing, which is the pointed cone on the very top of the rocket. This protects the payload from aerothermal loads, heating, and contamination during ascent. Now, once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit. While Mr. Steven, our ship, will not be supporting today's mission, we do plan to recover the fairing pieces from the ocean using our recovery ships Go Searcher and Go Pursuit. And lastly, you'll notice the tall structure next to the rocket, which we call the fixed service structure. Its primary function is to provide passengers access to the Crew Dragon vehicle during crewed missions. But since we do not
Okay
have any
then,
passengers
we'll
aboard
end this
today's
video
flight,
here,
the fixed
so
service structure does not
hope
have
you
a
all
role to fill.
enjoyed and
Now
peace
let's
out.
check